Thank you for joining to me. My name is Tadesse from Ethiopia. I'm here today to talk about our work impacts of homophone normalization for Amharic natural language processing. Amharic is a Semitic language family and the second most widely spoken Semitic language after Arabic, and also serves as the official working language of the Federal Democratic Republic of Ethiopia. When we see the origins of Amharic language, Amharic alphabets are totally adopted from Giz language. Giz also a Semitic language and ancient topic language. There are different characters in Amharic or Giz that have the same sound, but different in meaning and shape, which are called homophones. So online communities tend to use those homophone characters inconsistently. This means, for example, in the standardized word, the first character sounds ha may be replaced by those 6 types of ha. To study the usages of those homophone characters, we have collected and analyzed around 5 million sentences, and we have built word-to-vec and fast text embedding models. And lastly, our work analyzed to that the usages of homophone characters in Amharic text is mostly inconsistent, especially in the online community, and normalizations of those homophone characters into a single representation has a negative impact on word embedding models, because the current trend in Amharic NLP work is normalize those homophone characters into a single representation. We have motivated through this to analyze Amharic word corpus, the usage of homophone characters, explore the impacts of normalization on word embedding models, and propose how to address standardizations of Amharic language. As objective, this work is aimed to explore the impacts of homophone character normalization for Amharic language, collecting a large general purpose dataset, because Amharic language is a low resource language, and to build different word embedding models. For this work, we have trained word-to-vec and fast embedding representations of words with Jensen Python library and 200-dimensional vectors. We have collected text data from different publicly available sources, like around 2 million sentences from news, 1 million sentences from previously worked researches, and around 2 million sentences from Twitter. And we have used to train word embedding and fast text models around 80 million words from 5 million sentences. Our approach looks like this. I have wrote text sentence from news, Twitter, and from web corpus. And we have do pre-processing like text cleaning, tokenization, segmentation, to word and sentences, and normalization. We have trained those word embedding models with normalization and without normalization. And when we see top similar words that obtained from word-to-vec, the first two column words have different writing but have the same meaning, and the second two column shows homophone words that have different meaning according to the homophone character they contain. And the top similar words shows that they're more similar to the target words, and also the third column shows its meaning is poverty, and the similar words are related to poverty. The fourth column shows salvage, and the results are related to salvage. Those two words are homophones, they have the same sound phonetically, but different meaning according to the homophone character they contain. After normalization, those homophone characters are changed to a single representation, and these columns are missed, or we don't have these columns when we make normalization. So when we see the graphical representation, those three words have the same sound but different in meaning, and also those three words have different meaning but they are homophone, and also the representation shows they are a little bit scattered because they have different meaning. As a conclusion, this work is the first work on the effects of homophone normalization for Amharic texts, and we have analyzed web corpus related to the online community, and the online community does not follow the standards of Amharic language. Our work is employed word-to-vec and fast text embedding models with skipgram and common bag of words methods with and without normalization. And normalization, lastly, we have seen that normalization have a negative impact on homophone words that have different meaning. In the future, we have planned to study the effects of homophone character normalization on other different semantic models that will be used by different NLP tasks like named entity recognition, sentiment analysis, question and answering, and information retrieval. So lastly, these works released different outputs like datasets or raw text for the coming research purpose, because Amharic is a lower source language, and this work releases datasets around 5 million free text sentences and source codes for the modules, and the pre-processing source codes are available, and pre-trained models, around 8 pre-trained models for word embedding, models for word-to-vec and fast text embedding models with and without normalization by using the methods skipogram and common bag of words. Around 8 models are word embedding models are available through this contact. This is all about this work. Thank you.